Good day, students. You are welcome back to our class. We are still on cable and wire. In the previous class, we looked at wire gauge and cable selection. In this final class, we'll be looking at cable rating and derating. What is cable rating and derating? Cable ratings depend on certain factors. For example, a good rated cable selected may behave strange due to these factors. We're going to see those factors as the presentation progresses. If a cable is rated 40 amperes under 25 degrees Celsius, for example, you are not sure that this cable will still maintain 40 amperes if the temperature is about 40 degrees Celsius, because more temperature means more resistance of the conductor and that more heat. So cables must be directed to account for the changing conditions. If you have a cable rating, when the condition changes, you have to apply those changes in the condition to see if the rating will be changed. Will it be operated or derated? Heat, which is the I square R or the Joule loss, is the main reason why cables need to be directed. So we are looking at all factors that will increase the heat of a conductor. Factor those things into your design, and then you'll find the normal rating of a conductor. Some factors affecting cable temperature and rating are considered below. For instance, skin effect of conductors. You know that current don't use up all the cross-sectional area. They tend to flow at the skin of the conductor. At high temperature, the skin effect increases, and this means increase in the resistance of the conductor, and therefore heat increases, because the more the resistance increases, the more this heat, its I square R, increases. Another factor is proximity effect. When the conductor is just, there's one conductor inside, either inside the conduit system or buried, or whichever method that you are using. If it's one conductor, the heat will be less. But if you have two conductors, three conductors, the heat will increase. So the more the conductors, the greater the heat, especially the skin effect also will contribute to this. Another factor that leads to the increase in heat is the installation method. If the cable is air-cooled, it will dissipate heat easily. But if it's in a conduit pipe, it will not dissipate heat easily. Same as when it is underground, the heat dissipation will be less. So air conductor that is in the air, like surface wiring, will cool easier than the conductors in conduit pipe and underground. Another factor to be considered is cable bearing depth. The more, if that is for underground cable, if the depth of burying the conductor is much, the heat dissipation will be less. Therefore, the heat retained in the conductor will be high. Ambient soil temperature. Some places are hot, tropical areas and temperate areas are not the same. So if the conductor is installed in a place where the soil temperature is high, it will reduce the rating of the cable. Soil thermal resistivity. This one is about the inverse of the soil conductivity. If the soil is thermal resistive, which means that it's not easy to dissipate heat via this soil, which means that the higher the thermal resistivity of a soil, the hotter the cable will be when it is buried in such soil. Another factor is load factor, which is about how the load is being used. If a cable is under use for all 24 hours, all time, it will be hotter. But if the cable is to be used for some time, there are some breaks, it will be less hot. Another factor is the insulation. As we saw in previous videos, the insulation types are not the same. There are some insulation that withstand heat more than others. So if you check that the conductor you selected, the insulation does not support certain amount of heat, maybe you need to derate the conductor so that the current carrying capacity will go down. and therefore reducing the heat here. We're going to take some examples. So what is the rating factor? It is a number without units, which this number multiplied with the current to find the new capacity, ampacity, that is the current capacity of the cable as the operating conditions change. I take example. So if what I just said here I express in a formula, it means that the new rating of a conductor is considered as the rating factor K multiplied by the old rating. Let's take this example one. A twin core cable of 10 mm square PVC cable rated 40 amperes at an ambient temperature of 25 degrees Celsius. What will be the new rating if the ambient temperature changes to 60 degrees Celsius? Take the rating factor as 0.44. So it is cross-sectional area is 10 mm square. The rating is 40 amperes. The temperature for that rating is 25 degrees. So when the temperature changes to 60, what will be the new rating? Assuming that the rating factor K is this. Solution: old rating is 40 amperes. The rating factor is 0.44. So the new rating of that cable will be K times the old current rating, which is 17.6 ampere. Something that was carrying 40 amperes is now derated to 70.6 ampere because of the condition that changes. That's so interesting. So we move on. Another example, a 96 mm square cable rated 186 ampere is laid underground. This one is underground laying in soil with temperature of 40 degrees Celsius. That's the soil temperature is 40 degrees Celsius, and the thermal resistivity is 150 degrees Celsius centimeter per watt. That is the rating of the units for thermal resistivity. And the laying depth is 1.5 meter. The question is, derate the cable with respect to the operational conditions. Taking the rating factors as laying depth K1 is 0.95, soil temperature, the rating factor is 0.9, and soil resistivity, the rating factor is 0.91. So we are going to apply these things to find the new ratings of the conductor, because this is the rating of the conductor, not considering that it is buried underground and with all these conditions. Okay, solution. The formula remains the same. Old rating is equal to 186 amperes. Now, the total derating factor, you are going to multiply all the derating factors, K1, K2, K3, which is this. Then you can now get the equivalent K, and you apply the method. The new current is the derating factor multiplied by the old current, which is 145 amperes. So it's actually coming down from 186 to 145 amperes because of the operational condition. Manufacturers provide the rating factors for several possibilities. So a cable comes with all these factors. But where insufficient, there is IEC standard for choosing the rating factor of anything you want. There are tables that IEC provided for several conditions, and then the rating factors. So that is all for the video. Up next is assignment and the quiz. See you next time.